So now that we've graphed systems, hopefully you've realized that this is not the most efficient method of solving. In fact, it can be very tedious and time-consuming, and if the graphs are not just perfectly beautiful, it can be very messy and aggravating to try to get an answer. So instead, we would solve a nonlinear system algebraically, and this is much more precise and much less irritating than trying to graph quadratics. Okay, so looking at number 4, we have y equals negative 3x minus 8 and y equals x squared plus 4x plus 2, a linear and a quadratic. Notice they have a y in common. So what that means is we can actually use substitution and plug one equation into the other. So what I mean by that is I'm going to take this negative 3x minus 8 and I'm going to put it in place of that y on the second function. So I'm going to write negative 3x minus 8 equals the x squared plus 4x plus 2. Now this is a quadratic, so in order to solve it, I'm either going to factor, or I'm going to use the quadratic formula, or complete the square. I'm going to do something to solve this, but most of those methods kind of need it to equal 0 first. So I'm going to clean this equation up by adding 3x, and I'm going to add it over here to the 4x. So now that's 0. I'm then going to add the 8 over to the 2, because that creates 0. So my left side equals 0, and my right side is going to be x squared plus 7x plus 10. So this is a much simpler equation to deal with. Now, if it bothers you to have the 0 equal, you can always move the 0 to the other side, but you don't have to. So now that this is a standard form, hopefully you notice that 10 is going to very easily factor. Okay, it's going to factor into 2 and 5. So if you've forgotten though, 10 is 1 times 10 and 2 times 5, and then x squared is just x. So this is going to factor into x and x, plus and plus, 2 and 5. If you've forgotten the factoring, you can use the quadratic formula, but it's going to be a little more work. So now that we have these two factors, we can set each of these factors equal to 0. So x equals negative 2 and x equals negative 5. Now here's where you have to be careful. You're not done. Okay, all you have done is found the x values. But we're looking at a system, and this system has x and y. So what that means is we need to find our y values. To find the y values, we're going to plug back in to one of these equations up here. So we can use the top one, or we can use the bottom one. Now here's the great news. You get to pick which one you want to use. Because since these are the points where the x's are the same, this is also the points where the y's would be the same. So if you plug it into the top one, you get the same answer as the bottom one. So when we're doing this, we need to be kind of attentive to the fact that a linear equation is much easier to simplify than a quadratic. So I'm going to take these values and I'm going to plug them in up there to my linear equation, just to save myself some time. So this first equation, we would say y equals negative 3. Well, that x becomes a negative 2. So negative 3 times negative 2 minus 8. And we'd simplify that down. So this is going to be 6 minus 8, which means y equals negative 2. So our first answer would use the point negative 2, negative 2. That's our first solution. That is a point where they would intersect. Now, our second one, plugging that version, that equation, that x equals negative 5, y, again, I'm plugging it into negative 3x because that one's so much easier to work with. So this is going to be 15 minus 8, which means y is going to equal 7. So this particular point would use the negative 5 and the 7, so negative 5, 7. So those would be our solutions, negative 2, and negative 5, 7. So if you were to graph these two equations, those would be the 2 points of intersection. Okay? So let's try number 5. Number 5, we have a quadratic and a linear again. So again, you're simply setting them equal. These are equal to y. So all you have to do is take this and plug it right there in for y. So we're going to have x minus 5 squared minus 3 equals negative 2x minus 3. Now this is a little more complicated because we have this lovely thing right here, x minus 5 squared. So it's very tempting to say that's x squared minus 25. That is wrong, because x minus 5 squared means x minus 5 times x minus 5. So right now I'm only working with the x minus 5. So that's what this is, x minus 5 times x minus 5, which means if you multiplied it out, you would have x squared minus 5x minus 5x plus 25. 4 terms, not 2, which simplifies down to x squared minus 10x plus 25. So all I have done is this green part, this x minus 5 squared. So now what I need to do is I need to tag on the minus 3. You can't forget that minus 3 right there. He's hanging around. And I'm also going to tag on the equals negative 2x minus 3. So, so equals negative 2x minus 3. So again, it's a matter of cleaning things up. So I'm going to add this 2x over to the 10x. And I'm going to add this 3 to this 3 right here, because that's going to create a 0 pair, which is kind of nice. So I have x squared minus 8x. This is 0, so just plus 25. Now, I might want to try to factor this, but knowing the factors of 25 are 1 and 25 and 5 and 5, none of that's going to add up to an 8. So what that means is I've got to pick another method. You could use complete the square. You could use quadratic formula. It's kind of your choice here. I'm going to use quadratic formula because I think that's what most people would probably prefer. So remember, our quadratic formula is x equals negative b plus or minus the square root b squared minus 4ac all over 2a. And again, our a is 1. That's our a. Our b is negative 8, and our c is 25. So when I'm plugging this in, I need to make sure I'm attentive to that fact. So negative 8 plus or minus negative 8 in parentheses squared minus 4 times 1 times 25 all over 2 times 1. So the first thing I'm going to clean up is that discriminant. So 64 minus 100, that's going to end up being a negative 36. Now, as soon as I see that negative 36 underneath that radical, we should have a little bit of a wait a second moment. Because if that discriminant is negative, that means, sorry about that, so that would mean that our solution would be complex. This means we have a complex solution. In fact, we have 2 complex solutions. Well, we don't have this graph in the complex realm. We have a line which doesn't enter the complex realm at all in a quadratic. They have to meet up at a real solution, a real point. So if the solution here is complex, that means there's no intersection point. So our answer for this particular problem would be no solutions, because there aren't any real solutions that work. We get a complex solution. So there are no solutions, no intersection points between these 2 graphs. Okay? If you have any questions, make sure you write them down. Okay, these are the 2 solving linear systems algebraically. So now we're going to look at a word problem.